Making a video, physics video. Got a bit of a headache, but anyway, I wanted to make a video just because I haven't made one in a while, and so I have been just doing a bunch of thinking and such, and so I'm thinking about experiments. So this little fiber optic wires, tubes of glass. Anyway, and I was thinking about the sourcing of light, in the two-slit experiment, that you could get a pretty, you could get fiber optics to have independent sources very close to each other, and see if I can duplicate anything. So far nothing magical. I have to set up the camera for trying to video some of it maybe. I mean, the effects are interesting, but I don't know if they're telling. Obviously using diminished light source, and so it's a little more complicated obviously to see something when it's less light and all that crap. But anyway, but I was thinking about the two-slit thing, and just I've been researching, thinking and watching stuff, and so I'm just trying to compile it in my own head. But there is a fundamental problem, with the two-slit. The explanation given, it's more than just this. It's more than just the idea that photons have all this character that only reveals itself in this circumstance. It just seems kind of wrong. But it violates some, fundamental things like the speed of light. I didn't really realize that when you really think about the two-slit experiment, it's entanglement. It's a lot of things again. It's this whole idea of, you have to break the laws of physics essentially for this to happen. And it just doesn't make much sense, from my perspective. So anyway, the common explanations, you see out there, again, and they always sort of misrepresent, how the experiment should be drawn, is that, the two-slit experiment really is the micro-impediment experiment. There really is no, the separation is infinitesimal, as they say, essentially, compared to the diameter of the slits. And lots of different phenomena that's very kind of non-intuitive. You have multiple impediments. Then all of a sudden your pattern gets more and more refined and separated. So it increases the separation of the image interference pattern, where, intuitively it'd say there should be more noise, not less noise. The pattern shouldn't get bigger and bolder, it should get smaller and smaller. But anyway, so the fundamental math kind of goes like this. Like the photon comes in, does this magical go through both thing, at the same angle, and that somehow there's this diffraction or whatever, where they end up at the same place coming from these different locations. And just fundamentally, you can just kind of figure out that one of these two lines is going to be longer than the other. Okay, any non-parallel is going to lead to one line having to be longer than the other. And so, how do you explain that? I mean, with the speed of light, as a rule. And let's just concede that gravity isn't faster than the speed of light. Nothing else that we know of is faster than the speed of light. So then how does this accomplish this task of ending up at its destination, even if it's out of phase? I mean, the argument is it's out of phase. Well, if the experiment is done with a single photon, it's argued, it has been done that way, that you get the same result. So you'd have to argue that the single photon, has this real problem of getting to the destination regardless of what its phase is, regardless of where it is in this cycle of this wave. It had to get there faster than the speed of light. It had to travel too much distance, more distance than something moving in a straight line at the speed of light. It traveled more distance and got there at the same time, even though it's out of phase. I mean, it can't get there late. It has to get there at the same time, theoretically, to make any sense. Well, anyway, so that doesn't really go anywhere for me. Another part of this whole thing is this interference pattern, is described as it's described as this nothing. Well, you end up with the bars. The bars are the important part, right, where the nothing is. So there's nothing. What's sort of interesting about that the nothing isn't really what you would think, like the low point of the wave. So it's almost like alternating current. That this light, the wave has peaks and dips, and right at the center it still has peaks and dips. So as you move the filter in, you should have double peak and double dip. And the nothing really is where both of those cancel out perfectly and you have a straight line. So that's another part of this that's a little kind of non-intuitive when you think about it. This interpretation that somehow double down, the double recession, the double low, is perceived, is seen as exactly the same as two peaks. So, that's sort of not intuitive. One would think that the completely negative state of the photon would be its lowest state, not some middle place. It's just part of it. It doesn't ring true somehow. So anyway, I don't have anything new to add except that I think it is refraction. And so I'll blend this subject with these other subjects in the sense that, I've been doing some thinking about what moves photons, right? And so the argument here is that there's sort of the movement is it's being created somehow by the slits. I think people might argue that the destiny of the slits based on where in this, where they might interact, and that the fact is that they have to be in a certain position. So you can start kind of go backwards and figure out where the origins would likely to have been for you to have a certain location with a photon getting there, even with this wave mechanical stuff. It was. Well, I'm just going to argue that do we have any evidence that photons are moved by anything else than interaction with matter? Like there is really such a thing as a force that moves a photon. And because they're using this idea that photons are moved by gravity as a way of detecting gravity in the source, in the cosmos. And so they had to invent dark matter and dark energy because what they were getting in terms of lensing results were indicating more or less gravity in locations where there's not enough matter, not enough visible matter, in the sense not enough stars producing light. And so they had to come up with these explanations of this idea of this dark matter. And I would argue that lensing is being created by photons interacting with ions and other charged nuclear particles, alpha, beta, whatever, and that those particles, the density of those particles around a system or in a system is dictating how much light is refracted and therefore how much lensing takes place. And so it has nothing to do necessarily with gravity. So I guess I'm making the simple argument that this isn't a good way of testing for gravity using lensing, because lensing I think is happening based on density of charged particles. So there would be a relationship certainly between suns and these ions. It's kind of like the stuff that the solar wind, this idea that the northern lights and all that kind of stuff. I mean, there's a whole bunch of stuff being spewed by the sun that doesn't necessarily, that some of it does reach escape velocity, but much of it doesn't, and it just goes out and then flows back in through gravity, and it takes it a while for this to take place. And so there's this dense field in the solar system of charged particles created by the sun, and those particles are the things that are diffracting light if you were to look at it through our solar system. So it really depends on how dirty the object is, that essentially it's producing the particles, or maybe it has to do with how new the system is. You know, how much stuff is, like the asteroid belt, how much stuff is smashed into each other, and how much of that dust is still in the system that hasn't fallen into the sun yet. So based on the age of a system, you could surmise that it might have a lot less of those small particles in it, because it's had time for the gravity to slowly consume them, to filter them out. So anyway, I just think that's one of these fundamental mistakes that has been made, is this, and it seems rather a complete reliance on lensing as a way of detecting in systems as you can't do time lapse of, or some other, where you, in a system where you don't have the luxury of being able to see visually in some other way relationship between two things. But I mean, they have that. This is sort of like they have gone with things that they see it one way, and the lensing is saying something else, and they're going with the lensing rather than the physical observation. So they're so glued to this idea that gravity does move light that they're discounting what they see as a relationship, a Newtonian explanation maybe, and just reject that and saying, let's not pay any attention to what we see, in terms of how the suns are interacting with each other and what appears to be the gravitational relationship between the two masses. And instead they're going with, well, no, there must be something else going on because there's too much lensing taking place for the amount of gravity that appears to be there. Well, anyway, so I'm just saying that's how glued they are to it, that they're rejecting the evidence of what they observe and see, and instead are going with what they're surmising based on a theory that light is bent by gravity alone. Well, anyway, so if somebody has evidence of light actually being bent by gravity alone, like traveling through a vacuum, a pure one, and actually being bent by gravity, I'd like to see it. It's not devastating to what I'm saying, but I'm just saying it would validate the idea that you need more than just gravity to bend light. You need particles. Light goes from point A to point B in a straight line, and it just doesn't care about gravity. It just doesn't. Alright, because light's made out of gravity would be my argument. It's already traveling the speed of light, and you really just can't mess with it. But anyway, another interesting subject is, that we're on this subject. I was getting into some of this refraction stuff, the angle of incidence in the idea that stuff reflects, and if there is any such thing as a real reflection, in the sense that, and they still talk this way, which is sort of annoying because I think physicists know better, but they talk about how light moves slower through glass or through water, and you're like, you really don't mean that, right? I mean, you really don't mean that a photon is moving slower. You mean that the photon is interacting with a lot of stuff as it goes through the medium, and it's the distance of those interactions. Bounce, 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 absorb, spin, absorb, spin, absorb, spin. It's those interactions that are consuming time. Also the distance of those interactions. Distance is time. T equals D. That's, that's as fundamental, as E equals MC squared as T equals D. Distance is time. Right. Alright, but there's a certain angle, right, where you get to this certain angle of reflection off surfaces where 100% of what goes in will reflect off. But is it a true reflection? Or is it a reflection that's just pure, in that there's only one absorption and one release. Like say the photon comes into the surface, and the surface has electrons and atoms, and what happens is the photon is absorbed by, say, an electron in an orbit or something, and then it's released. So it goes into a magnetic field, and then it's released. It's captured, and then it's released. Magnetic field's the wrong word to use, obviously, but I just mean it can associate itself with photons that are moving in its direction, and so if it can become part of the snake of photons, let's say, or the I don't know how the right way to say it is, but anyway, it can become associated. A photon can become associated with a photon, but the consequence is that this orbit now gets bigger by the addition of that photon, and then the orbit becomes unstable, and therefore it has to be ejected. And so that's all I'm trying to say is that that's the nature of reflection. Reflection is it goes in and then it comes out, but it's doing this angular thing because it's consuming some extra time. There is a little bit of, you slow something down a little bit with each reflection. So I guess that would be a sort of an interesting experiment, is to reflect light, at the acute angle many times, off many mirrors. But I guess that's sort of what a fiber optic cable does, right? So the speed at which light is slowed down, well, see, it's also traveling through a medium, which is the plastic or the glass. So you can't really use that. I mean, you have to know how slow the medium itself is. How much of that is slowing it down. Just colliding with the molecules of the substance, and then colliding. But what a fiber optic tube is basically doing is it just keeps bouncing light at that acute angle, so it can't leave because it keeps 100% reflecting inside the tube. So as long as the angle isn't big enough, it can't get out of the tube. It just keeps 100% reflecting, so it just bounces off the sides all the way through the tube. So, but it would be kind of complicated to figure out how much it was slowed down by each reflection off the sides versus how much is slowed down just traveling through a medium that's also full of little particles that it's interacting with as it's going through that too. So that's too complex, I think, to figure it out. Well, anyway, argument is that maybe we can just do the mirror thing, a bunch of mirrors at acute angles, and just see how much light is slowed down by having to interact with the mirrors. But again, the mirrors are made out of a substance, atoms slowed down, has to go through the glass of the mirror. So I guess they'd have to be just pure silver kind of mirrors or some other kind of substance. Well, anyway, I don't know if that's been done, but it would, because this consumes time. This idea that it gets absorbed and then it's readmitted consumes time. Not much, but it consumes some. But light doesn't slow down. Light's always going. All it's getting is trapped somewhere. Again, this is just... So I mean, they're just saying this wrong. And I just hear it now. I watch these videos and they're always talking about the pull of gravity. The pull. That is 80% or 85% of the way it's stated as a pull. It just isn't... There's just no concession to the fact that the forces push. It just doesn't fit with their preference, let's call it. Maybe 10 years ago it wouldn't have fit with mine, I don't know. I think I always kind of felt kind of pushed. So I mean, I was always kind of looking at gravity as... I was always looking up there, to tell you the truth. I've always, so, I mean, maybe this is, telling in some way of why I ended up here, and at any rate, is just that it's always seemed like rain. I've always thought of gravity as something coming down, not something pulling me down. I've never felt like I'm being consumed by the earth. I always felt like I was being driven into it. So that's just that intuitive thing. So what else do I want to do? Lensing, angle of refraction. And the speed of light thing, it's just so critical. Like I think any theory, description, that has built in it some presumption that something can communicate based on information provided moving at this faster than the speed of light would tend to be bogus. So a photon reading the environment with like a radar that moved faster than it was moving and detected the environment ahead of it just doesn't make much sense. So again, this gets into this mass, which is also sort of interesting, and relativity, absolute versus relative motion, and what a force, what something's energy is. The energy is, in my opinion, photons, and that every detectable photon is really at least 2 photons. That's what creates the wavelength, the frequency, the distance between them. That's another thing that's just so, I've talked about it before, but that the energy it takes, the non-wave that creates waves, the force that creates a wave, is very different. The thing that plucks the string is very different than the wave traveling through the string. The vibration the string acquires is very different than the mechanism that creates it. The mechanism that creates it has to have jarring velocities. I've argued this before, but if I want to move my hand up and then move my hand back down, I have to accelerate very fast, and then I have to slow my hand down, and I have to stop my hand, and then I have to speed my hand back up again. So the velocity, if you were to just draw it as a as a thickness, going up, you're traveling your velocity very high, then you have to slow down to get to the peak, and then you have to speed up really high velocity and push your way down and slow down at the base again. And that's the force, that's the motion necessary to create a frequency, a wave in a medium. And so this ends up being an interpretation of this. It's not the same as it. What happens to the medium is different than what the thing that caused it is doing. So if you look at the wave interference pattern, you can sort of see that it's a digital pattern, and that digital pattern could be something made up of the fact of this digital interaction with photons and electrons, or even photons and the atoms in general. Is that there's motion. This electron is moving. The electron itself is swirling. You have all these different movements made in here, and that there would be a tendency, likely, that this only does this, just like that reflection deal, where you have to have this low angle, and then you get 100% reflection. So everything in this angle has the same exact. It does the same thing in the sense that it will not go this way. It will not go through the medium. It will bounce off. And the same kind of rules would exist inside of atoms or electrons, where they're only going to behave a certain way under certain circumstances. And that's what's being revealed in the two-slit experiment, is the fact that atoms do not, or electrons, let's say, when a photon goes in, they will not release one at this angle. They can either do like 50%, 25%, or 50%, but they can't do odd numbers. They only do something based on a pattern. The rigidity is built into their structure. And you sort of see that with some of the constants. They have these different constants. One of the important ones is called, what the hell is it? Alpha or something. And it's this 137 number, right? It's supposed to be a big important number. I still haven't quite figured it out. It's not in any units. It's just 137. It's okay, cool. It has something to do with energy and frequency and stuff, but I don't, and it's the relationship between energy and frequency, something like that. But anyway, but yeah, the point is that there's this rigidity to this mechanical system, and it can't, it does things in a kind of digital way. Things have to meet strict circumstances, and there's a strictness to the laws of those circumstances. So anyway, that's not exactly where I wanted to go, but this is just an important feature of this whole thing, is this recognition that this is see, I would argue that all sound waves are created by instruments that have to move faster than the speed of sound. That somewhere in this creating motion, you have to move faster than the speed of sound, or you can't create enough distance in the same amount of time. So to create a frequency, you have to have enough time to get to the top and back to the bottom again. And so you have to be able to create a necessary disturbance in the medium. There's just the rule that you're going to have to, somewhere in this motion, move faster than the speed of sound to create a wave that will propagate through mediums that carry sound. It's just a rule. Anyway, and the same kind of rules apply to the creation of all these things that are called waves. So what my argument is that light is this. Light creates waves. Light is not a wave. The photons are deliberate things. They do this all or nothing thing. So another way you could convert this kind of thing is to say it's all or nothing. You're either at this point or you're at this point. And photons are either there or they're not there. Right? There's photon, and then there's space, and then there's photon. There's nothing analog about it. It's either there or it's not there, or it's not there. And then there's another one, it's there and it's not there. It's all or nothing. But it's that frequency of the all or nothing. It's the frequency of that peak that is converted into the wave. But the photon doesn't have any wave built into it. The photon only has association with other photons, and it's those associations that create all or on, off, on, off. Photon, space, photon, space, photon, space, photon, space. That's what's creating the wave. But it's an all or nothing thing that's creating the wave, it's a very binary thing. Okay, enough on that, I believe. So what else did I want to... I know there was some other thing that I wanted to bring up. I did the two-slit thing, the frequency thing, the gravity thing, lensing thing. Yeah, that's sort of an important one, is to find some sort of absolute evidence. But again, I was talking about the relativity, and the fact that I believe it's an absolute. Your velocity is absolute. It's all combined. It's obviously relative. Me and this bottle have the combined velocities that are identical. Whatever our true vector through space is, and we have a true velocity vector through space. We might not have any movement at all, but that seems unlikely. So we are moving through space, the entirety of space, the objective space, with exactly the same combined velocity vector, whatever that may be, this way, that way, up, down, whatever we're doing. And so having the same neutral state, consistent state, now everything's relative between us. Now we can depart from each other's path, and we can see that departure. So in that sense there's relativity, but there's an absoluteness underneath it all, and that's what creates what we define as mass and force. Energy is just merely directionality of that stuff. So again, I've made this argument with the school of fish thing, but the idea is if you just think of photons as being one energy, then you can just calculate that something already has in it, all matter, every atom has a bunch of photons ready to go somewhere, ready to be released in a direction. But they're right at the moment trapped. They're being obliged to run the same course over and over and over and over, the same path. So they're not going anywhere. And the only way you could detect their force is to somehow interact with them. But you can't, because they're going in such a tight circle that I can't get to them. I can't stick my finger in and have them bang into it. So their mass, their force, their everything about them is neutral to everything else, because it's not impacting anything. It's not colliding with anything. It's just traveling an infinite amount of distance in a very small amount of space. But as soon as you start migrating, adding velocity, more and more of those photons, more and more of the bits that make up the electrons and the protons and the neutrons, more and more of those bits are tending to go in one direction more than any other direction relative to each other. They're already moving in an absolute direction. We don't know what that is, but it's already an absolute direction. And they're being changed as something moves. Whether they're being changed or they're changing it, it doesn't really matter. But the point is they're being influenced by gravity, or some other photons moving into it. So when I did this argument, the light comes in, what it ends up doing is imparting directional information to this electron. So this electron will end up perhaps moving in this direction a little bit, because the exchange was this one is now moving in this direction. So that change in direction, it imparts whatever the change was. So however this thing changes, in a kind of a conservation way, you wouldn't think of it as conservation because we think change requires energy, but it doesn't require energy because this is energy. Energy doesn't use energy when it changes direction. So what's happening is this one changes direction by a certain angle, and this body also changes direction by a certain angular momentum. I mean, it won't be, obviously it's affecting something much more massive than itself, so the effect of that extra motion will not be as obvious. It won't get the full angular value out of it. It has to do it in increments, so it's affecting some of the photons in the electron, and then if enough photons are affected, the electron will move. But I'm just saying it's imparting a value, a tendency, an element of I'm going this way is imparted, is transposed into the thing that made this electron go out this way. But you can sort of see that with gravity. If I use the moon, you know, to get back to the Earth, to preserve my preserve my velocity, I use the moon's gravity, and I get captured in the moon's gravity, and then I leave. The fact is, I will affect the moon. It ends up being neutral because I'm going back to the same point. But if I was to use the moon's gravity, if I was to go into the moon's gravity, spin around a few times, and then go out at some other angle, not the same angle I came in at, I would end up pushing the moon a little bit in that direction. You know, the equal but opposite angle. The moon would end up being pushed a little, based on the fact that I left it a different direction. If you leave the same way you came in, everything will end up neutral, because you'll just be consuming the vector. The vector you gave will be the vector you'll subtract, is the point. But if the two don't subtract and there's a remainder, that remainder is imposed on the thing you interacted with. Yeah, I think that's pretty. I think even physicists would grant that sounds right. I think. Anyway, so what do I want to do with this velocity thing again? Yeah, so it's this whole idea of mass. Mass is just a function of your acceleration, essentially. A function of your velocity. And so you have built into you a capacity to have velocity based on your based on your atomic mass. It's not the right way to say it. Mass is something we talk about based on what it seems like you have based on what gravity will do to you. What a given gravity will do to you. But gravity is accelerating you. And that's how we're detecting mass, is based on having some portion of your substance moving. But your actual mass is the thickness of the density of your atomic weight. That your atomic weight is your real mass. And atomic weight doesn't necessarily correlate. Well, I don't want to say that. That weight is always exists. That's the E equals mc squared part. Your atomic weight is your real substance, and your velocity is just how much of your substance is moving in a direction. So you gain more force as you move faster because more of your substance is moving in that direction. More of the fish in the school are moving in the direction, and all mass is directional. All energy is photons, and it's all about what they hit. They hit something. They have no mass in any other direction but the direction of the thing they hit, so to speak. There's just energy. There is no mass. Mass is just a storing of energy. There, that's probably the way to say it. A trapping of energy. Mass is just energy trapped. I mean, again, it's just as simple as E equals mc squared taken literally. Alright, anyway, enough of a video. So anyway, I'm going to do some more. I mean, I have to do more mathematics tying this together, but I want to do better math. I mean, I want to do, like, this is why you multiply this times this, and this is why you square that, and this is why you take the tangent of that. I want to do math that's more explicit. Not just, here's the formula, the end. It works. Yeah, I want to do something where you understand why it works. You understand the relationship that's causing the effect. And again, I have to do it just because I have to come up with I have to come up with a more truly explicit description of not only lensing but the two-slit experiment. And this does have to do with a rather complex relationship between, the fact that light, when it's refracted or you have reflection, refraction, and diffraction. Yeah, I know. Well, anyway, when it's doing that, it can involve many more than one interaction. The reason why it changes direction is not because it has one interaction and it changes direction. It can have many interactions, and each interaction is creating a change in direction. And it's the cumulative effect that you're looking for. But it seems clear that there has to be a lot of interaction, especially, like I said, in the two-slit experiment, because so much of the light is being refracted, diffracted. It doesn't matter. Anyway, so till next time. Thanks.